if there are no questions on any of the assignments, we're going to go on and look at the rest of the note sheet from yesterday, dealing with addition and subtraction. So let's go on and put Chromebooks away and headphones out. Thank you. Now, when we add or subtract two rational expressions, we want the denominators to be the same. We want the denominators to be the exact same. So when we look at this here, we're wanting the 2x minus 2 and the x squared minus 4x plus 3 to be the exact same so that we can add or subtract the numerators. So for the starting point, we're not going to do anything to the numerators. But what we want to do is factor the denominators as far as we possibly can, and then go from there. So the first one we can factor is our 2x minus 2. Now, there are only two terms, so the most we can do is pull out a greatest common factor of 2. And if we factor 2 out of 2x, we get x 1. Because if I factor 2 out of 2, it factors out completely, leaving us with just 1. Now the other set of parentheses, or other denominator, our x squared minus 4x plus 3, doesn't have a greatest common factor, but we can factor it with two sets of parentheses with 3 spaces. Now, since the 3 is positive, the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. X and x, because that would be the factors of x squared, and 1 and 3. And those are the only factors of 3. Now, we've got both of those factors, so it's going to be a little bit easier to see what we need to do to both sides to get the denominators to be the exact same. Let's get a highlighter. So the first thing we want to look at and see is what is the 2 times x minus 1 have that the x minus 1 times x minus 3 does not. The 2. Because it does have an x minus 1, but the only thing it's missing is the 2. So to get these to be the same, I need to multiply this one here by 2 over 2. And that would get them to be the same, or at least closer to it. Because now everything that the left one has, the 2 times x minus 1, the x minus 1 times x minus 3 will have. Now let's go the other direction. What does x minus 1 times x minus 3 have that our 2 times x minus 1 doesn't? The x minus 3. So I'm going to multiply the top and bottom by x minus 3 and x minus 3. So here, well, if I'm right, we're going to multiply each of these rational expressions by our sets of terms. Now the denominators are actually going to end up being the same because we're going to have 2 times x minus 1 and 3. And this one here is going to be 2 times x minus 1 and we want this to be the case because the only way we can add or subtract is if the denominators are the exact same. Now we can multiply the numerators, and we're actually going to multiply them out. So we can do x times x, which is squared. X times 2 is going to be plus 2x. Negative 3 times x will be negative 3x. And negative 3 times 2 is going to be negative 6. For the other one here, we're just going to multiply both of these terms by 2. So negative 2x times 2 will be negative 4x. And negative 1 times 2 is going to be negative 2. Any questions on any of this here? Well, the next thing we need to do is, well, we need to combine like terms and we need to subtract. We can do this in one move, so we're not having to rewrite this a whole bunch of times, like we did, I think, yesterday. Now, if we look at the first one here, because we do have our x squared. But interestingly enough, we do actually have 2x and negative 3x, yes? What is 2x minus 3x? Negative 1x, yes? So when you say minus x, minus 6. So I decided to kind of do that in one main step. That way we don't have to rewrite this entire thing over just to combine 2x and negative 3x. Okay. Two. Well, it'll take care of itself here in a minute. Oh, it's going to scroll down. So, if we look at this here, the first set of parentheses we really don't need, because there's nothing in front of them, the sign's not going to change. But the second set with the negative 4x and negative 2, we're subtracting it. So if I subtract the negative 4x, well, that negative and negative would make a 4x. The negative 2, subtracting a negative 2 is going to make it plus 2. And this is going to be over 2 times x minus 1 times x minus 3. Any questions on any of this here so far? Well, the next thing we need to do is just combine our like terms and then see if we need to simplify it all. So, if we look at this here, well, our like terms that we have on top, x squared does not have any like terms. There's no other variable with an x squared. So it just stays x squared. Now our negative x plus 4x is going to be plus 3x. 4x minus x would be 3x. And last we have negative 6 plus 2, or 2 minus 6 is going to be negative 4. And this is going to be over 2 times x minus 1 times x minus 3. So we have finally actually subtracted the two from each other and gotten 2x squared plus 3x minus 4 over 2 times x minus 1 times x minus 3. Now the numerator does look like we can actually factor it. And if we can factor any of the numerators in any of these problems here, we need to. We need to factor this down. Because if it works out that one of these factors is in common with one of the ones on bottom, then they will simplify out. So we look at x squared plus 3x minus 4. Well, since the 4 is negative, our signs are going to be opposite. One is going to be negative and one is going to be positive. Now the factors of x squared are x and x, and the factors of 4 are 1 and 4 or 2 and 2. We need it to be 1 and 4, and which one would be negative? And the 4 would be positive. And this would work out to give us a positive 3x. Now we knew the factors couldn't be 2 and 2 because there wouldn't actually be a middle term. X plus 2 times x minus 2 would be our factorizations of the difference of perfect squares, which x squared plus 3x minus 4 is not. But when we do this, does it give us something in common on top and bottom? Well, yes. The x minus 1. So what that means for us is that these here will simplify out, leaving us with x plus 4 over 2 times x minus 3. And that there's as simplified as it gets. Now, it's not going to always work out that the numerator will be factorable. And even if it is, we are not guaranteed that there's going to be something in common on top and bottom. But we still need to factor the numerator all the way out just to make sure that there's not. This is also why we don't multiply the denominator together. We don't multiply the x minus 1 times x minus 3 and get, for this here, it would be x squared minus 4x plus 3, because then we would have actually had to factor it back out to be able to see this here. So on all the denominators, we'll leave them in the factored form, because we'll eventually have to simplify. Any questions on this here? Okay. Let's look at another one. Now with this one here, just like with the first one, we're not going to mess with the numerators yet. But we do want to factor the denominators as completely as we can so that we can see what we need to do with them to get them to be the same. Now we can factor the x squared minus 3x plus 2 first. Since the 2 is positive, the signs are the same and they match the sign of the middle term, which would be negative and. X and x would be the factors of our x squared. And 1 and 2 would be the factors of 2 that we would want. So x squared minus 3x plus 2 would be x minus 2 times x minus 1. Now we still need to factor our 2x minus 4. Well, they both do have a greatest common factor of that we can factor out. And if we factor 2 out of 2x, we're left with x. And if we factor 2 out of 4, we're left with 2. So we get 2 times x minus 2. Any questions on this here? Now it is kind of interesting that we do have the negative 2x minus 1 being subtracted from the other. And just like the one before, really this negative in the middle is going to make the negative 2x and the negative 1 both positive, because we'll have to multiply it through. But it'll work itself out. Now, we need to figure out how to get the denominators to be the same so that we can actually subtract these two from each other. So when we look at these two here, well, the first thing we can look for and see is what does the denominator x minus 1 times x minus 2 have that the 2 times x minus 2 doesn't? X minus 1. So to get them to be the same, I'm going to multiply this one here by x minus 1 on top and bottom. I've still not figured out why it's doing that. Yeah. So that there would give us a denominator that would be closer for both of them to be the same. Now we need to see what does the 2 times x minus 2 have that the x minus 1 times x minus 2 doesn't. They're just missing a 2. Now at this point here, we can multiply these together. Now the denominator will give us 2 times x minus 1 times x minus 2. It's going to be the same for both, which is exactly what we wanted, because if we're going to be able to add or subtract these, we need the denominators to be the exact same. Now if we multiply this numerator by 2, well, 2 times 5x is 10x. 2 times negative 1 is negative 2. Now in our other numerator, well, we're going to have to distribute all the way through. So we're going to have to do our negative 2x times x, which will be negative 2x squared. Then we'll do negative 2x times negative 1, which will be plus 2x. Then we'll multiply through with the negative 1. Negative 1 times x is negative x. And lastly, negative 1 times negative 1 is going to be plus 1. Any questions on how we got to this point here? Now, what we can do next is we can combine like terms and get these on the same rational expression in one move. Because we'll have 10x minus 2 minus, well, we would have negative 2x squared. We do have the like terms of 2x minus x, and 2x minus x is plus x. Because if we have two of them and take one away, we just have one left over plus 1. Because I think you'd all feel comfortable doing that one move together, yes? Because we could have rewritten this entire thing and just changed the fact that that is a single x. But I think that's a little unnecessary and a lot of extra work just to add two terms together. Now, at this point here, we can go on and do our subtraction. Now, the 10x minus 2 isn't going to change. But when I subtract a negative 2x, well, the negative and negative makes it positive. Whenever I subtract a positive x, well, it's just going to become negative x. And when I subtract a positive 1, I get negative 1. And now we can go on and combine our like terms. If we look at all of this here, well, 2x squared does not have any like terms. But we do have a 10x and negative x, and 10x minus x is plus 9x. And lastly, we have negative 2 minus 1 is negative 3. And this is over 2 times x minus 1 times x minus 2. Any questions on any of this here? Yep. Now, what we need to do is look at the numerator and see if we do have a greatest common factor, something's in common with all three terms. Well, there's not going to be a number that's divisible by both all of 2, 9, and negative 3. It just doesn't work. And I don't think there's any way that we can get the factors of 2 and 3 to multiply together to give us 9. So, this right here is the final answer. That's as far as it'll go. Any other questions on this here? I still find this kind of funny that we go from the ones that have kind of the more complex denominators to now 4x and 7. Even though I set these notes up and did it this way, I still kind of find it funny that I didn't put this one more to the front and at the end instead. But we'll look at this one here and one more, and then we are actually done for today. We have 2 left. Now, we still want to get these denominators to be the same. So we're still going to multiply both by something to get the denominators to be the exact same. All right. N7 over 7. Now with variables in our sets of parentheses, it's not too bad because we only have to really count up or look at them and see. We need to be careful with numbers for like 4 and 7 because there might be a number smaller than it that does work for the least common multiple. And I mean, if we wanted to check it, one way we can do is look at the multiples of 4 and the multiples of 7, 14, 21, 28. Well, 28 is the first number that both of these turn into. So it works out that this is the correct setup. Now, if there was one smaller than it, the only real issue we would run into is that we would have to factor whatever that is out later. So if we go above 28, which I think the next one might be 56, we would have to factor out that greatest common factor of 2 that we added in. But these here would be the smallest. Now in the denominator, well, 4 times 7 is 28. X, 7 times 4x is x. So we do have the denominators being the exact same. And we multiply the numerators, well, 7 times 3 is 21, and 1 times 4x is 4x. Well, we can go on and subtract them. So 21 minus 4x over 28x. And looking at the numerators, is there a greatest common factor between 21 and 4x? Well, no, there's not a number that will divide into both of them evenly. Both of them don't have a variable, so, well, that is as simplified as it gets. I mean, we could write it as negative 4x plus 21 over 28x. I mean, that's the same thing. It's just putting the variable first. Here, we're not too concerned about x being negative. The only time I would worry about a negative is if it was in the denominator, then I would want to move it out front or move it to the top and distribute it through. But either one of these here is the same thing. They're the correct answer. Any other questions on this here? So we'll look at one more of these here. I'll let y'all pick between the last 3 that we have which one y'all want to look at. I have a feeling I know which one. This one? This one here? Okay. So we also have... So y'all want to look at this one here? No? Okay. Let's look at this one because this one is on the, or a similar one is on the homework because we've only dealt with 2. Now, guys, we do need all 3 of these to have the same denominator. So just like the ones we've been doing, for the first part, we're not going to mess with the numerators yet. We're going to leave the numerators as they are, and we want to factor the denominators. Well, x minus 4 is not going to factor any further than it already is. And x is already simplified. Both of these are simplified. But the x squared minus 16 is factorable. And how would we factor this? It would be x minus 4 and And now that we have all these factored, we need to see what we need to multiply each one by so that the denominators are all the same. So if we look at the x plus or x minus 4 here to start with, what is the middle one, the x have, that the x minus 4 doesn't? Well, it's missing n and big X. And then the last one, the x minus 4, x plus 4 has an extra x plus 4. So we would also need to multiply this by x plus 4. Over here, plus 4. Yeah, had a little difficulty in writing that. So the first one, as I throw that, the x minus 4 on bottom is missing an x and an x plus 4. So to get them all three to be the same, we needed an x plus 4 and an x. Now let's look at the middle one. Well, it only has an x. So what is it going to miss? What is it missing? So what is this x, what does the x minus 4 have that the x doesn't? It doesn't have n? 4. And it would also need an x plus 4. Because we need all three of these denominators to be x times x minus 4 times x plus 4. We needed to have all three terms. Now, out of all three of these here, when we multiply the numerators, well, the 4x is going to be the easiest one to multiply first. Well, it's 4x times x, which is 4x squared. 2. We can do the middle one next because we're going to need to multiply x minus 4 times x plus 4, which would be where did we get the x plus 4, x minus 4 from? Didn't we get it from right here? So it would be x squared minus 16. In some of these here, and we'll see this in solving, if we're multiplying two together that we actually factored to get them, factored a polynomial down to get them, might as well just replace it back because we know where we got it from. But that does leave us with the last one here, x times x plus 4 times x minus 2. We're going to actually have to multiply this out. Well, let's go on and multiply the x with the x and 4. Well, x times x would give us squared plus times our x minus 2. So we'll need to multiply this out. So we'll do x squared times x will be cubed. X squared times negative 2 will be negative 2x squared. 4x times x is going to be plus x squared. And 4x times negative 2 is negative 8x. Now we can multiply the middle one, 2 times x squared minus 16. Well, 2 times x squared is squared minus 2 times 16 is, and we still have our 4x squared. And well, the denominators of all these are x times x minus 4 times x plus 4, x times x minus 4 times x plus 4. And lastly, we have x times x minus 4 times x plus 4. Now we need to add and subtract these together. Now we will combine the like terms in each individual expression. So like the first one here, well, we do have x cubed negative 2x plus 4x squared is going to be plus 2x squared minus 8x plus our 2x squared minus 32, and then we have our minus 4x squared. Now at this point here, we don't have to worry too much with the negatives because the first two, with it being added, is not going to change the sign. The only one that we do have a subtraction with is 4x squared, well, it's just going to be minus 4x squared. Any questions on this here? And this is still all over x times x minus 4 times. Let's combine our like terms. Well, the biggest one we have is x cubed, but it's all by itself. Now we can combine our x squareds. Well, we have 2x squared, as I color over the top of it apparently. Because we have our 2x squared plus 2x squared because 2x squared plus 2x squared is 4x squared, and 4x squared minus 4x squared is 0. So our next one is our minus 8x minus 32 all over x times x minus 4 times that's it. Since we have the x cubed, if we were going to be able to factor it, well, I would need it to be x cubed minus a perfect cubed or plus a perfect cubed. And since we do have more than 2 terms, I would actually need 4 to be able to factor it by grouping. So this here is as simplified as it gets. And that there would be our answer. Any questions on this here? Well, that is the end of our 7.41 notes. And this is your homework assignment.